Hey there, class. We're here today. We're going to look at solving a mathematical problem involving uh, horizontal kinematics. So let's go ahead and get started, shall we? When we solve our problems in my class, we are describing some situation, and often the problems we're given are in words. Our goal will be to take that, put it into pictures, equations, and graphs. In this particular video, I'm going to focus mainly on the pictures and equations section. So without further ado, let's take a look at our question. So we have here example 2, and I'll let you go ahead and read it. But basically, we have a plane, and it's trying to take off. And it looks like we have a runway that's 150 meters long, and we are wanting to know if this plane has enough room to actually take off. So let's start off by showing we understand what's going on by drawing our picture. So let's see, it must reach a speed of 100 kilometers per hour. So I know that this plane must be, let me just copy it here and then get it here. I know that it's starting over here and it kind of accelerates down the runway and it gets to some place over here where we're going to say that this is where it obtains this takeoff speed, which in this case is going to be 100 kilometers per hour. I think it's fair to assume that usually when the planes start here at the end, I think hopefully we understand that usually they're starting at rest. So that's 0 meters per second. And this would be what I would refer to as my original velocity, where this over here is what I would reference as my final velocity. I'm also knowing that in between the snapshot of here and here, this is my original snapshot, and this my final snapshot, that we are undergoing, or the plane is undergoing, an acceleration. And that acceleration is going to be, looks like here, right there it is. It looks like it's 2 meters per second squared. Okay. I also, let's see, I don't know anything about time, and it looks like the runway is 150 meters long. Now, I'm not going to draw that in for just a moment, and you'll see why. I'm going to kind of skip over this point in here in just a moment. Okay, so I've summarized what I know, what I don't know, and I'm going to get to the finding here in just a brief moment. So the first thing is I noticed that my initial velocity is 0 meters per second, final velocity is 100 kilometers per hour, and acceleration 2 meters per second squared. Now, right away, this is the place where I like to check things. I like to see if everything's in the MKS system, meters, kilograms, and seconds, and I notice this guy is in fact not. It's in kilometers per hour. So without actually showing the work here, to do a conversion, what I'm going to end up with after my conversion, and again, if you're curious about this, I've shown how to do conversions in another video, but basically I'm going to convert it into the MKS system, and I'm going to end up with 27.8 meters per second. Now, you might say, well, isn't delta x this 150 meters that is listed up here in my problem? And I'm going to argue that is not necessarily the 150, the delta x. Okay, so if you take a look at our runway here, there's a distance of 150 meters. Now, in no way, shape, or form does this problem say that it reaches 100 kilometers per hour at 150 meters. All we know is that the plane has this much distance to use to get there. We don't know that it's traveling 100 kilometers per hour at this 150 meters. So here's kind of where we get into our strategy. We don't actually know delta x. Delta x is going to be what I'm going to actually try to find. All right, and so let me explain a little bit more here as I get into my strategy. Basically, I want to find, okay, I can use constant acceleration. That's usually a good assumption in our kinematics problems. Use constant acceleration and kinematics equations. And we're going to then compare the delta x that we find. So the delta x that we found, compare it to the d. All right. So pretty much, if we find that the delta x is less than d, that tells us one thing, or we might find that delta x is greater than d, which tells us another thing, and we'll talk a little bit more about that here in just a moment. Okay, so before we go over and kind of figure out which equation we want, I've drawn in my delta x here, which, again, we don't know if it's equal to, if it's greater than, or less than the 150 meters. I'm going to assume it's less than. I'm hoping that our planes are going to have enough distance. So I've drawn it that way. We'll figure this out here in a little bit. Also, something else to note, I always want to make sure that I give my vectors directions. Since all my vectors that I've drawn are to the right, it makes sense to call that direction positive. I've made that adjustment down in here in my knowns as well. All right, so on to equations. So basically, because I'm looking for delta x, and I have the information here, I want to look for an equation with delta x in it. So right away, I'm going to remove a couple out of the picture here. I'm going to get rid of this one because it doesn't have delta x in it. I'm going to get rid of this one because it doesn't have delta x in it. And it looks like all the other ones do, in fact, have a delta x. So next thing I'm going to look for, I notice that I don't have time. So any equation that has time in it is probably not another one that would be good for. So my first one has time in it, I'm going to get rid of that one. This one had time in it, so I'm going to get rid of that one. This one has time in it, so I'm going to get rid of that. So we're basically left with this very last equation. And let's just double check. We want to find this. This is unknown. We have our acceleration, we have an initial velocity, and we have a final velocity. This looks like a good candidate to use. So here we are with the equation. I like to, at this point, make a look for any substitutions that I can make that make it easier. And we do have, of course, it's starting at rest. So that would take this out of our equation, the initial velocity. The final velocity, something I know, we are going to end up with 2a delta x. And again, I'm trying to solve for the delta x, so I'm going to divide both sides by 2a. And that's going to cross off here and here. And I'm going to divide this side by the 2a. So that will actually give me delta x equals the final velocity squared divided by 2a. All right, let's go ahead and substitute and solve it. And let's see what we end up with. Okay, so I've substituted in my numbers and I have done the calculations. Now, one thing I'll put a note out here is one red flag that you want to look for. This is very common when using this equation. I see a lot of students often forget to square this. And again, you can see that the velocity is being squared, so make sure you don't forget that when you actually do this math. All right, when I put this in my calculator, I end up with 193 meters. All right, and so step 2 of our strategy is to take this number and actually compare it with the d. Of course, d equals, if we go back to our knowns or back to our picture, we'll see that it was 150 meters. And delta x, which we found, which we're not really writing it as a vector here, I guess, so I'll just say that magnitude of it, it's just 193 meters. Now let's think about what this actually means, and I'm going to go back up to my picture for what that means. Basically, what this is telling me is that the plane starts at rest, accelerates at 2 meters per second squared, and reaches or obtains a speed of 100 kilometers per hour, and it's going to require this delta x for that. We have a full length of 150 meters, and we're finding that in order for it to accelerate to that speed, it is going to require 193 meters. So I have to think about, what does that actually mean? Well, if it requires 193 meters to get to the right speed to take off, 150 meters is actually too short. So to respond to the question, which was how does the runway long enough, I would basically say no, the runway is not long enough because the delta x is greater, or you could say something like the required distance is, the required distance is longer than the runway. So to fully respond to our question, we would have to recognize that that distance that we have is not actually long enough for this plane to take off.